The collision between these great tectonic plates form the major features of the Earth's topography, or the shape of the surface of the Earth. In this illustration of the tectonic plates, we noted that these great plates are first of all formed by layers of both granite that make up the continents, as well as basalt that form the ocean basins. And therefore, as the tectonic plates are pushed outward from the mid-oceanic ridges, they collide with the adjacent plates, and one of three types of collisions is possible. There can be a collision between an advancing continent and an oceanic plate, as is the case along the west coast of North and South America. Or it could be the collision between two continents, as occurred when the Indian plate rammed into the Eurasian plate, forming the current mountain zones of Central Asia. Or finally, it can occur when two oceanic plates collide, as is the case in the Pacific Ocean. First, let's look at the collision between a continent and an oceanic plate. This illustration, imagine, shows the collision between the Americas, North and South America, and the Pacific Plate. Imagine, for the purpose of this illustration, that you are standing in Alaska looking south. North and South America are on your left and are on plates advancing from east to west, or from left to right in this illustration. On your right is the Pacific Ocean. And when these plates collide, three things happen. First, the collisions are not smooth, because as the plates advance, pressure builds up. The plates cannot slide easily underneath one another because of friction. And as the pressure builds up and finally snaps, we have the formation of earthquakes. Secondly, when this occurs, the heavier, thin basaltic plate, in this case of the Pacific Ocean, slides underneath, or what is called subducts, under the advancing edge of the granitic continent. As the basaltic plate declines deeper and deeper in the earth and falls under the great weight of the advancing continent, the basalt melts, forms magma, a liquid substance that expands and finally bursts through the surface of the granite, forming volcanoes. And finally, this process of earthquakes and volcanoes leads to the buckling of the granitic continent and the uplift of mountains on the advancing edge. These three phenomena, earthquakes, volcanoes, and mountain formation, are quite evident on the west coast of both North and South America. Here we have a photograph of an event that occurred at 5:05 p.m. Prior to Game 3 of the 1989 World Series between the New York Giants and the Oakland Athletics. This was indeed the shot heard round the world, a visual representation of the great Oakland earthquake of 1989 that was televised. Not the most destructive earthquake in history, but certainly the one most visible to the largest number of people. Here again is a shot of Mount St. Helens, a volcanic mountain in the state of Washington that erupted in 1980, creating the greatest destruction of any volcanic eruption in the United States. And finally, this topographical map of the Americas shows the great mountain chain that runs from Alaska in the north down through the Canadian Rockies to the American Rockies and Sierra Nevadas, down through the Sierra Madres of Mexico, and all the way down the west coast of South America, forming the great Andes Mountains. This photograph of the Andes on the border between Argentina and Chile reminds us of how high, jagged, and therefore new and uneroded these mountains are. This mountain formation, which continues, has produced the highest and most rugged mountains in the Americas.